We can also look at determining the end behavior of functions just using limits without looking at the graph of a function. First, we'll look at some cases with linear and polynomial functions. In order to determine the end behavior of a function, we need to know that that means find the limit as x approaches infinity of f of x and find the limit as x approaches negative infinity of f of x. In this case, our function f of x is just negative 5. Doesn't matter what our x value is as it gets bigger, smaller. Our function is a constant value, so our limit in both directions will just be negative 5. The limit of a constant, regardless of what x is approaching, is always just that same constant value. In example 11, things get a little more interesting here. We'll take the limit as x approaches infinity of g of x, which in this case will be negative 5. Well, let's pause for a second here. Stepping back, now that we have a variable in our function, what we can do is identify the term in our function with the highest power. In this case, that's negative 5x. That's where we have x raised to the largest power. Because what will happen is as x gets incredibly large or incredibly small, that term is going to be the one that impacts our function value the most. When we deal with really small values, negative 5x, subtracting 1 could make a bigger difference there. But once we're plugging in values like 10 million, 10 trillion, 10 to the 100th power, whatever that is, once we start subtracting 1 from numbers like that, it doesn't really make much of a difference. And the same thing would happen if we were plugging in very, very small negative numbers. So as we're considering the limit going to these of x going to these extreme values, everything but that dominant term really stops having much importance. So really what we're going to do is consider the limit of just negative 5x. And we'll consider the limit as x approaches negative infinity of negative 5x. Because again, any other terms just don't carry as much weight or have much impact when we're considering the scale of the numbers that we're substituting in. From here, there are different ways to figure out what this limit result should be. One technique that I use is just to put in sort of a placeholder concept versus like a number. So we're going to plug in values for x. In this first case, we're plugging in really, really large values, so large positive values. So what I'm doing is taking negative 5 times some really large positive value, which means I'm going to have a negative times a positive, which means I'm going to get a negative infinity. I'm taking 5 times some incredibly large value, so that's getting closer to infinity, but then I am multiplying it by that negative, which is going to flip the value to be negative. When we consider that same idea for the limit as x approaches negative infinity, now I'm taking negative 5 and I'm multiplying it by a negative value, a really, really small value. So like negative 10,000, negative 10 billion, negative 10 trillion. So I'm taking a negative times a negative, which is going to give me a positive infinity. Because 5 times some really, really, really large number is going to be infinity, but then both of those values are negative. Those multiply together to cancel out, so we're still just left with a positive infinity. We can do the same thing with examples 12 and 13. Again, we only need to consider the term with the highest power. In this case, for example 12, that would be negative 4x to the 6th. In example 13, that'll be negative x cubed. In example 12, we'll take the limit as x approaches infinity of negative 4x to the 6th, meaning we're going to get negative 4 times some positive value, some really large positive value raised to the 6th power. So that really large value raised to the 6th power will be positive times a negative 4. We'll switch that to be a negative infinity. And then we'll consider the limit as x approaches negative infinity of 4x to the 6th, negative 4x to the 6th. Now we're taking negative 4 times a really small negative number, but it's raised to the 6th power. A negative number raised to an even power will be positive. So now we have a negative number, negative 4, times a positive. So this will again be headed to negative infinity. Again, there are different ways to think about this. You could just plug in larger and larger values in your head or with a calculator, but somehow we just need to think about what's going to happen with the signs of these different terms and whether things are going to be headed to positive or negative infinity. For example 13, we'll take the limit as x approaches infinity of negative x cubed, which will give us negative times some really large positive number raised to the 3rd power. So that positive number raised to the 3rd power will stay positive, but then multiplied by that negative out front, we'll flip this to be negative infinity. Then as x approaches negative infinity, we'll get a negative times this negative value raised to the 3rd power. A negative number raised to an odd power stays negative. So this will be a negative times some really small negative number, and a negative times a negative will cancel out to give us a positive infinity.